I'm meant to ask you a question. Just to introduce myself, I'm Ian Gent. I'm one of the people who nominated Patrick for this award together with Barbara Smith and Toby Walsh. And Patrick has borrowed my t-shirt. Which is rather disconcerting because it looks to me like I'm looking in a mirror, but with a beard and more hair. So Patrick, how do you feel about winning this award?
Stunned, I think that would be the best word. Pleasantly stunned. It was a fabulous surprise, really. A great honour. It means a lot to me, really. Really.
And do you want to say anything about people that you work with?
No, because this is all entirely my own work. It's been deserved by me and me alone and these 46 people. So these are the people who've written papers with me. Bruno de Banker, Chris Beck, Peter Burke, Paul Cockshott, Vincent Furlong, Ian Gent, Holger Hoos, Rob Irving, and he gives us our nice Erdos number.
Yes.
Yes. Phil Kilby, Andrea Coltes, Ewan McIntyre, who most of you will know as Ewan McIntyre.
Yeah.
No one's ever spelled his name correctly. David Manlove, Neil Moore, John T. O'Donnell, Greg O'Malley, Yevgeny Selensky, Paul Shaw, Barbara Smith, Costas Stergiou, Chris Unsworth, Vin, and I can't pronounce Vim's surname, Vander Ball, Rick Wallace, Toby Walsh, Woo Wee, Rebecca Mancy, Simon Rogers, Alice Miller, Christophe Lecoutre, Ken Brown, Peter Gregory, Kevin MacDonald, Bill Johnson, Musin Bouzouba, Gear Hassler, Craig Brind, Claude Muller, Chris Conway, I think Peter Burke.
Yeah.
Already. Yeah, Peter Burke. John Costello, Ian Buchanan, James Campbell Hendry, who I wrote my very first paper with, Stuart Grant, Evan McGill, what's Brahim's surname? Is it
Hinish?
Hinish. Patrick Cross is in this list, and most recently Pankaj Singh. So I make that 46 people involved in this award. So by my calculation, which is always very bad, that's 2.17% of this award I claim for myself. The rest I share with my co-authors. But since it's my 2.17%, I can do what I want. I'd like to dedicate it to John Gashnick. And that's
So
it.
can you say something about John Gashnick, since I know he's a hero of yours?
Yeah, I think his works in Constraint Satisfaction has been beautiful, elegant, simple. He's done wonderful experiments, especially when you consider when he did them, the compute power that was available. His analysis was always lovely and honest, nothing was hidden. It was just first class.
Okay, well,
Right, that's it.
we've got another 45 minutes to
Right. I feel incredibly lucky that I've got something that I am that enthusiastic about. I'll give you a little example. The first time I had cancer and I went through chemotherapy, I would get up in the morning, you lie in bed, you're feeling like used food, and you think, okay, I have to get up, and I would take 48 pills. And then there'd be other pills, that would be the chemotherapy that was weighed out. And then you'd have other pills to counter those effects, to maintain kidney function, liver function, anti-nausea tablets. So it's a pretty daunting prospect. But whilst I was going through that, I found some interesting work to do on singleton arc consistency. And I found somebody on the web who was doing it, Christophe Lecoutre. And Christophe and I were doing what I do it with other people, communicating, emailing code, experiments, results, text. So it's, what, do I get up and take chemotherapy? Was that the first thing I mind? No, it's let's get up and see what Christos results has got. And that was just fabulous to have, for Christoph to lift me through that. So I'm forever grateful to Christoph because of that. So I think it's fantastic to have something that you're that interested in that is that much fun. Especially for me now. Especially for me now. That's Tara.
Hello, Tara. Oh, I'm just...
That's for Francesca. Rossi would like this. This is Tara. Very affectionate. Okay, down you go, darling. Oops. Together.
Okay.
So I think the first thing is, so this is how I got to do the work on conflict-directed back jumping. So it was 1986 to 89. We had a project. It was Alvi funded. You might remember that, British government. And I was brought in to work on the project because I developed a factory reporting system. So we're going to build a scheduler on top of it. And I had the idea that what we should do is to put a scheduling agent on each machine in the factory and allow them to communicate and resolve conflicts. So in some ways it was a real push forward because PCs were just coming online. They were quite expensive things. So it was really distributed artificial intelligence and distributed constraint satisfaction problem. So we viewed the problem as one of satisfaction, but the key thing that we needed for this was that each agent had to be able to react to a problem, because one would make a schedule and transmit the change in time windows to other resources. So they had to be able to react. The other thing is if something was over-constrained, they had to be able to supply back an explanation so that we could retract it. So you could see all the things were coming into place about reaction and explanation. So pieces were coming together, and they were coming together through a practical application. So it was the application that was driving this development. It wasn't that, it wasn't intentional. So in this system we had three classes of agents. We had operational agents, so these were the ones that actually did the scheduling on resources. And the first time we ran it, the whole system went chaotic. So today that wouldn't be a surprise, but to us, you had to implement it to discover these things. So we put something above it, which we call tactical agents, and they did load balancing between those agents. So the agents below could send up no goods, conflicts. The T agent would then put this into a truth maintenance system and then use it to resolve conflicts and do load balancing. But then we still got chaotic behavior. So we had something at the top of the T agents, which we call the strategic agent. So strategic, tactical, operational. And the S agent could relax the problem by relaxing due dates or by adding in new resources, which could be people on the shop floor or an additional machine. So the O agent, the operational agent, was essentially made of something I called explicit forward checking. So I called it EFC. So I'd read about forward checking, I'd implemented it, but I did it explicitly, so all the nuts and bolts and levers and hydraulics and cables were there rather than done recursively. So when they're there, you can start looking at them and see what else you can do with them. So they were explicated. So that was my piece of work, developing the agents. Now the first agent we called the naked runner, or I called the naked runner. So this had no truth maintenance, no explanations, nothing. It was just a fast piece of code that would run to the solution and couldn't tell you how it got there. So when the problem changed, if it was adding a constraint, so it became more restricted, it was easy to deal with that. But if you relaxed the constraint, you literally had to solve that agent's problem again. So then I came up with a version where we recorded no goods and did things with it, and that was called EFCDDB, explicit forward checking with dependency directed backtracking. And in fact, that was dynamic backtracking. So that was in 1989. So it predated.
So when you say dynamic backtracking,
it meant that when we find a conflict, we find a variable that takes part in an eliminating explanation, and we uninstantiate that. And when we uninstantiate it, we don't backtrack up to it, we pull it out down here. So we would forward check against it as we come down. So we retain all of the information in between. So it's almost like not a tree, it's a directed acyclic graph, the search space. It's rather complicated to do, but the thing was it preserved all this knowledge that we could then pass around as explanations. So obviously there were people around at that time that were very much influencing me. One of the things was the UK planning SIG group, where I met Barbara Smith, Edward Sang, Jerry Kelleher and Peter Ellaby. So Jerry and Barbara were interested in that time in constraint satisfaction and truth maintenance system. Edward obviously was at the heart of constraint programming, and Peter Ellaby was a real practitioner. He was very much a scheduler. And there are also papers at that time that were a big influence. I literally read everything I could get hold of by Rena Dechter, John Gashnick, there were only a couple of papers that were there, but they were very influential. Obviously Haralick and Elliott and Alan Mackworth's work on art consistency. So in '89 I went to ICHCAI. Yes, I did. And I presented a reactive scheduling agent, which was explicit forward checking with dependency directed backtracking. Now at that conference, fabulous conference, I get dragged into a workshop on scheduling by Norman Sadie, and Pascal Van Hentenryck was there. But one of the amazing things was outside the workshop there was a stack of reports, and this is the report. It's written by Bernard Nadell, CSC 85005, and it was on a stack, and it said $1, and I had $1, and I put it in the jar and took a copy away. Now, just looking at the paper, it's almost like a work of art. Let me just show you some of the pictures that we've got in it. Does that come up here?
Yeah.
Yeah? So, I mean, how could you not want to read that? Look at this kind of stuff. How about that for $1's worth? So I've got some more nice pictures. Microstructure. This is $1. So this was before the web, right? So, sorry, you can see I'm a fan of Bernard Nadell. So in reading this paper, there were bits in it that were just here's something he wrote in the paper. It says page 9. Something to think about would be a synthesis of backmarking and backjumping into an algorithm, say BMJ, backmark jump, he called it. We see in figure 1 and 2 that each algorithm avoids some checks that the other doesn't. Is it possible to combine both approaches while retaining all or most of the power of each? His preliminary attempt at such an algorithm suggests that the answer may be no. This is perhaps why Gashnick did not suggest such a synthesized algorithm. However, more thought on this is warranted. Now, isn't that lovely to put things like that in a paper? Because some years later, this is a paper I wrote. Can you see the title? It's called BM plus BJ equals BMJ. So, wouldn't have happened if I hadn't read this lovely paper. Now, when I'd read his paper the first time, Bernard Nadell, so remember there's no web in this time. It's difficult to get papers. So there was a news group called comp.ai, And I put out a posting there and I said, does anyone know the email address of Bernard Nadell? And this is some weeks later, I got this letter posted to me and it said, someone gave me this today, so I thought I'd write you my email address. I have to. And there's Bernard's email address. So Bernard didn't even trust the web at that time. So then we started up a number of conversations about his work. But he was just so supportive of me at that early stage. So another paper that was very influential was by John Gashnick. And this is his paper that describes backmarking. Now this is Ichkai, 77 I think. So again, this is something I really like. I could just do it on one page, but the downside is it took me about 3 months to understand it. If he'd written 2 pages, I'd probably have understood it in an afternoon. So that's backmarking. And reading Bernard's paper, he describes backmarking in 2 paragraphs, and very clear, lovely, lovely stuff. So where am I here? So I think it's also interesting to think why the paper that I wrote in Ichkai 89 was a bit of a failure. And one of the reasons was it wasn't very clearly explained. The second is that it was very complicated, and I want to quote something that Robert Tarjan said in one of his papers. He said, "It is one thing to have an algorithm that is theoretically good. It is another to have an algorithm that is simple enough that someone would want to program it and use it in practice." And at that time, explicit forward checking with dynamic backtracking, or DDB, failed that test. It was just too complicated. Anyway, so 1990, I wrote up the conflict directive adjuncting and submitted it to Ichkai in 1991, and it was rejected. It was turned down. So I wrote up a technical report, and again I emailed Bernard Nadell, and again, Bernard was emailing me, but he would also print off the email and post it just in case there was a problem. You can see his business card down there. Again, isn't that nice? So Bernard said, "Perhaps I can make a brief suggestion or 2 that may be of help. From what I can tell, your paper deserves publication. Sometimes it is harder to publish in a conference proceedings than in a regular journal, in spite of the fact that conferences count for less in terms of getting tenure, etc. Don't let the rejection by Ichkai 91 put you off. I'd suggest submitting directly to a good journal. In particular, I suggest computational intelligence, since that's where I published the paper, Constraint Satisfaction Algorithms, that your paper is based on." So, again, he's given me support when I needed it. And another email that he, rather than copy me in on the email, this is email he sent to Vipin Kamoor, and he printed it and again posted it to me. So Vipin was writing a paper for the AI magazine reviewing constraint satisfaction, and in this he says, "Lastly," so this is to Dear Vipin, "I have recently received the thesis and some papers on some excellent work on constraint satisfaction problem algorithms by Patrick Crosser, Strathclyde, Scotland." And he goes on, he says, "I encourage both of you to get in touch and recommend that you cite his work in your survey." So it's just nice when you see that other scientists and academics supporting others at critical points and the effect it can have. So there were a number of papers that came out of this as well. There was, I guess you can edit some of this out, but let me just get to a point. I think I got my papers in a bit of a mess. I'll just stop and get that. So, the paper in '93, I presented at the conference on artificial intelligence applications, the paper on backmarking and backjumping, and it was quite surprising. I don't know why I did this, but I used to write a review of the conference I've been to and make it available to friends and colleagues, and I kept some of them. And this is a review of the conference on 9th Conference on Artificial Intelligence for Applications, and it was held in the Disney Yacht Club Resort in Orlando, Florida. Now here's a nice fact. The 1st to the 7th of March is Speed Week at Daytona. It was estimated that there were in excess of 400,000 bikers in Daytona for that week, plus 5 Scotsmen. Brian Morrison for Kawasaki, Jim Moody for Yamaha, Ian Simpson for Suzuki, and Steve Hislop for Ducati, and me. I also met up with a number of American racers, those that I contacted via the net, Rec.Motorcycle Racing. I met Janet Gunn and her father. Her father is 65 years old and still racing. I know this because it said so on his shirt, and he's retired. He used to work at the IBM Research Labs, and when he was there, he developed a diode. Some of you won't get that. I also met Steve Tice. Steve is a software engineer, and he came in 8th in the endurance race and competed in the 600cc Formula 2. Motorcycle racing and motorcycle racers are the same the world over. I think that Daytona was my first and only glimpse of a familiar reality in Florida. Now, another point in this that I thought was interesting, this is a section I wrote here called Food for Thought. As one would expect, there was a conference banquet. I sat beside 2 Europeans, Frenchmen to be exact. The first course arrived. The conversation was convivial and not technical, so I've got a footnote here. We talked about motorcycles, Star Trek, and food. The main course then arrived with the coffee. We had a banquet without wine. This struck me as unusual, and decency prevents me from reporting what my French colleague said. There was an after-dinner speaker, and by the sound of it, he had more than just coffee with his main course. Anyway, one of the Frenchmen was our dear Christian Bessier, and it was absolutely a picture to see him drinking coffee with his main course in a banquet. So, and this is my last bit on the conference. On a personal level, I think that I am still a bit confused about my trip to Florida, and this may be a result of cognitive overload. Although this was not my first time in America, and although we share a common language up to a point, the landscape and everything in it, motorcycle racing excluded, was alien to me. Being in Walt Disney World didn't help much either. And here's a footnote. Everything in Walt Disney World is fantastic, including the hotel bill. On top of the room charge and sales tax, there was a Walt Disney World tax. Okay, so was CI 93 a success? Was this paper a success? And that doesn't really matter. It's okay, it's not going to. So going back to what Tarjan said, that for an algorithm to be successful, it should be simple. It should encourage people to implement it, to program it, and then use it. Everything in the paper, I think, was having looked at the algorithms explicitly and getting all of the data structures and information out of them, and recognizing that there was a forward move and a backward move, because things were done iteratively, it then became easy to combine them. It became like a mechanic's job. So things were simple, everything was explained from backtracking, then backmarking was shown just as a small modification, the same for back jumping, etc. So it was simple and incremental and easy. So elegant, this is from an interview with Tarjan. Elegant algorithms are easy to program correctly. It's much more likely to be used and you need to have confidence in the result it produces. So I think the algorithms here pass that test. So and here was another test that it passed. I deleted all the files by mistake one day, which was quite a wake-up call. And it only took me an afternoon to code all of the algorithms back up from memory without looking at anything. So that was another proof to me that they were simple and easy. Don't you stop for a minute?
Okay.
Or maybe I should just say a couple, well maybe just a couple of things, right? There are a couple of things here that I should say that what's still to be done. So there are things in the paper I left as future work. So actually in the paper I highlight 48 other algorithms that are still to be implemented, and I don't think they have been. I also identify room for improvement within forward checking, back jumping and conflict directed back jumping. And I should say who influenced me in this, right? So Oli Jakubitesta coded all of these algorithms up, as well as a final year student to check them. And originally, I'd called conflict directed back jumping GBJ. And in fact, in my PhD thesis, it's called GBJ. And Peter Hendry said, it's not that, that's the wrong name. And he called it conflict directed back jumping. So it wasn't even me, and obviously Bernard Adele helped me so much with this. But it's also just interesting to look at the references. Almost all of them are to Rena Dechter, so almost everything's based on Rena Dechter's work. Very big influence. And 2 papers by John Gashnick. So if we had your test, if you look at the citations to try and work out who wrote this paper, if it was anonymous, you say, Rena Dechter wrote this. It's Dr. Evil, and this is for Francesca as well. This is Rosie. Rosie. Here you go, darling. Yes. When this started, it was in the early 1990s, 1991. So again, you don't have the World Wide Web, you don't have Google, you can't just key things into Google and find papers and download them and read them. So you depended upon people to communicate with, friends that were working in the same area. So Barbara Smith and I had a nice arrangement that if we found some paper interesting, we'd copy it and put it in the post and send it to them. And so Barbara went to, Itchkai, 91, I can't remember, was that in Australia?
Yeah.
Anyway, she copied for me the papers that she thought were interesting, put them in the post and sent them to me. And this was the one that just blew me away, which was Cheeseman, Kaninsky and Taylor, where the really hard problems are, and they identify the phase transition. How did you get hold of that paper here? Were you at the conference?
So, I'm just going to sneak in so you can see.
Yeah, it's really there.
Interesting, quite a similar thing happened to me, but it was the next year, in 92, and in the research group in Edinburgh, in Alan Bundy's research group, people would give talks about papers they found interesting. And Toby Walsh came back from the conference, AAAI, and gave a talk about a follow-up paper to this one on SAT by some combination, in some order, Mitchell, Selman and Levesque.
Yeah.
And that's how I got interested in it. So it's quite a similar thing.
Yeah. So I started working this is 1991, and we had an open channel of communication, Barbara. We were emailing each other, sending each other program codes, bits of maths, results, continuously. And I also had an open line of communication with Tad Hogg. I don't know why I've done this, but I kept printed. Maybe it's the Bernadette effect. You print off your emails and put them in a file somewhere. And you think, well, is there a date on this? Probably don't even have a date. So this is the kind of things we were, modes of communication, the tables of results and running programs to analyse them and to check them, bits of maths. So there was one bit of maths where we got really confused. What's the date?
June 1993.
That's okay, so that's a bit later for that one. So we got some things where we couldn't understand. We weren't in agreement, and then we find out this should be M, not N. So amazing things like that, and then everything falls into place. So I don't think we started working together until, well, I'll get to it. So I then wrote a paper, and Barbara did too, and it's called Binary Constraint Satisfaction Problems. Some are harder than others. And this was the phase transition, so you see all our standard cuts. Everybody goes like this. You tell somebody who does phase transition research, it's like, bless you, Muslim. So there was a section, do you remember? And Barbara came on first, and she presented her work.
I've got a side note on this paper, this is the only paper of Patrick's I ever reviewed. Because I reviewed this for the conference, and I didn't know Patrick at that point. And then after that, we were too close, I couldn't review his papers anymore.
So it's Barbara first. There was one session, Barbara first. Did somebody drop their slides?
I dropped my slides.
And you were on next. Who's on next? It was Ian, Jet and Toby. And then we went and had a canteen lunch. So this was Amsterdam. And we walked to some sort of strange subterranean canteen, and there were only the four of us. And we realised we were all really should be working together. So it's like me and Barbara, you and Toby, and it became four. And we worked on this. So tremendous, absolutely tremendous amount of creativity. And there was also an AIJ paper that came out right about the same time. So we then went on and developed constrainedness. And there was a key moment in that. We went to a conference in France, and there was a beach, and there were conversations that took place on the beach outside the conference on this. So that's 95, CP 95.
Yep.
And then we came back and worked on a theory that would locate the phase transition, and it's remarkably simple. It's just based on the size of the solution space, the log of it, and the expected number of solutions. So it's very simple to use this. Anyway, so I'm going to see if I get any notes on this. Let's see. Now, it was, what would we say about kappa? It was this common parameter for what we would hope was the phase transition in any NP complete decision problem. And then you and Toby took it up above a complexity class to cover P space. And we also took it down to look at things like arc consistency. So there was this nice hierarchy, and it seemed to be consistent throughout it. I've always thought that every piece of work here should have kappa on the x-axis. But the other thing that was lovely is that we could use it to design heuristics to solve the problems. So we proposed that you make a decision that will minimize the constrainedness. So if you've got an equation for constrainedness, you could sit down and work out how to minimize it. So you could go into a problem you've never seen before and engineer a heuristic, Or you could go into an area that's using a heuristic and you say, is that the right one? Are they on the right track? And this piece of work has caused me a lot of frustration because, as I said, I think that everybody in this area should be having kappa on the x-axis, and I think that everybody that's developing heuristics should be looking at this to decide whether they're on the right tracks or not. And I think I know why that's not happened. Because of the title, the constrainedness of search. It should have been called a theory on the phase transition on combinatorial decision problems. And then anybody who types things in Google, this would jump up. So there's just a small number of people in the constraint programming area that they're using. So that's been cited a couple of hundred times, but it should just be the standard. So, in this way, I think that this paper's been a little bit of a failure.
My friend, he's attacking me. It must have been my title. I can't remember.
Well, I don't know. I've got my name on it too, so I'll have to take some of the blame. You know. So let me tell you what I've been doing recently.
Yeah.
On this, Pankaj Singh and myself have been looking at independent set and click, the same problem. And how did we get to that problem? David Manlove has been looking at the kidney exchange program for the United Kingdom, where you have couples. So maybe you need a kidney and Judith can donate it, but it wouldn't match you. And I need a kidney, Andrew would donate it, but it won't match you. So we could do something between the four of us. And then we could go to 6 people. So then you have to do 6 operations simultaneously. So you're matching these things up on a large number of people. So this is what David's doing. David's saving lives, absolutely wonderful piece of work. So I've been using constraint programming earlier on just to confirm his results, because it got to be optimal, as you can imagine. Lives are involved. And then abstracting away and abstracting it right down to independent set. So it reduces to that. So then you read so I was going to do experiments on it, and the first thing you do is say, okay, what are the heuristics I should use? So for independent set, you would think, oh, well, the heuristic would be to choose a vertex that's adjacent to least others. Yeah? And select it, and then pull another one that's adjacent to least others. And if it was clique, you choose a vertex that was adjacent to most, and pull it in, and keep doing that. So you code that up. You read the literature, you code that up. And then you think, well, if that's good, the opposite of it should be really lousy. And we can do these experiments because we don't need ethical approval. We just generate our own graphs, nobody gets hurt. And you do the experiments and you find out that the literature is wrong. So then you go and you develop kappa for independent set, kappa for clique. You work out how you would minimize it, and it says to minimize kappa for independent set, choose the vertex of highest degree. Because it leaves a subproblem with vertices that are more isolated. And conversely for clique. And you do the experiments and you get results that are orders of magnitude better. You go and you read in the literature, you open the handbook on algorithms. It says you choose, it gives the wrong heuristic. No evidence to support it. So this annoys me.
Anything else you think that constraints people should be looking at?
I can't think of that. I mean, it's such a it's such a discipline where people are moving on all fronts. But yeah, I think one thing that constraint programming community should be doing is making a point very so often publishing outside the constraint area. Go and publish in discrete mathematics or journals on algorithms to spread the word. I'll give you an example. I've been reading literature on independent set and clique, and I've read some papers where people say, and this is the best algorithm ever, and then you think, oh, hold on a minute, and you read a paper by Jean-Charles Regin. Jean-Charles Regin came up with an encoding for maximum clique, and he did his experiments, and he did them over all 66 Dmax benchmarks, reported these results, totally honest, beautiful piece of work, what you'd expect of Jean-Charles Regin. Right? You look at his results to those appearing outside the constraint literature, they're not citing it, they claim that they're faster. Gradually, over the last few years, some of those authors have picked up Jean-Charles' work. And you never guess what some of them have done. They've taken their 66 benchmarks, some of them report 44. So they exclude some of the results that Jean-Charles has produced and still claim that they're faster than Jean-Charles. So we shouldn't be allowing that. If we've got a good result, we should also publish it elsewhere so that people know. I've spoken to Jean-Charles about this. I know it's kind of official. So I think we need to go outside as well. Let other people know what we're doing.
Yeah.
I'm guilty of it as everyone else. Yeah. So we need to go and do that.
Patrick, I want to ask you why are we doing this video in your conservatory?
My conservatory, because I can't get this through the metal detector at Glasgow Airport.
Yeah.
Okay.
So we're sitting together.
Next year maybe. Oh, that could be a camera operator.
Hi. So we're having a conversation. I've got more than the average number of legs, and you've got less than the average.
Well, it's interesting if the average number of legs in Britain is less than 2.
Yes. The average number of legs in this room is less than 2.
Is less than 2. Zoe,
Hello there.
come here.
How you doing?
Hi.
Say hello. Come here.
Hi. We're doing a video.
Jen,
Oh,
sit down.
I see.
Sit down
Oh,
so you can actually see the head. How are you, darling?
Good, how are you
Good.
guys?
Okay.
Good.
Say hello to everybody at CP.
Do you want a cup of tea?
Yeah.
Yeah.
Do you want chocolates as well?
Yeah, alright.
Good.
How'd you take your tea?
Just white.
White.
Okay, okay.
Oh, you can chop things up and you get these bits
No.
and put in
We're
adverts.
just gonna.
Is it? It's just going to be
That's
like,
the way it is.
it's going to be like Apocalypse in a row.
Yeah.
3 hours. That could be cool, couldn't it? So. Finished?
So have I finished?
Yeah.
No.
No.
Have you finished?
I'm finished ages ago.
Oh.